Okay, let's give you guys some more practice. So here, let's say you've got a chicken. On this chicken, there's some bacteria growing on it. You then add a drop of bactericide on this population here, on the population of bacteria here. Then the population of bacteria is given by this equation here. Okay, so there's some bacteria growing on the chicken. You then add one drop of bactericide on this population here, and then the number of bacteria is given by this equation here. So looking at this here, try and mentally sketch it inside your head, or on a scrap piece of paper, sketch it inside your roughly sketch this graph. So here, looking at this, you've got t to the power 4, you've got t squared, you've just got t here, and here is just a constant. There's no t here. So this here is just a constant. So roughly sketch it just to get an idea of what's going on. So here, when t is small, it wants to do a linear, a straight line here. So the intercept here is 10 to the power 6. Let's just say it's around here somewhere, and then it will have a gradient of 10 to the power 5. Let's just say something like this here, and then when it's big, it wants to do this. When t is big, it wants to do this. So it will want to do a positive quadratic. So you would expect it to be something like this. Okay, but it's only valid when it's big, so it's around here somewhere. Okay, and then somewhere in the middle, that's going to give it a slight negative quadratic. So here, negative, and give it a negative quadratic. So looking at this here, give it a negative quadratic, like this. Okay, so now it's just guesswork now. So you could guess you could guess it to be something like this, and then here it would probably do something like this, or it might even cross over here. We don't know. So this here is just a guess. But then if you can, don't forget, you can find the exact coordinates of this point and this point by differentiating this line here, and then find out where it's when you differentiate this, if you want to find out the exact coordinates here, then differentiate this whole thing here, and then find out when it equals 0. So t here is a time in hours. So here, this is a time in hours, and this is your b of t here. So this the the y-axis, in a way, it represents the number of bacteria living on this chicken. So looking at this here, at time equals 0 here. But by the way, time equals 0. So that means before time equals 0, we don't really care about the graph. Time before 0. So you then added one drop of bactericide on this population here. But then the population still keeps on growing. It keeps on growing. It will take a while for it to decline. It takes a while for this drop here to take effect, and then after a while, then the population goes down. But then as time goes on, then the bacteria starts to grow again. So eventually, it will devour the chicken. Okay, so well, if you sketch this whole graph here, if you sketch this graph here, it will look like this. Okay, and then if you differentiate it, then you get this blue line here. So if you look at this, time equals 0 is when we start adding that drop. Okay, and then time equals 0 is when we start adding the drop. But then after adding the drop, the population is still growing, and then after a while, it then declines. Okay, so this bit here, somewhere here where the gradient is 0, that's when the population starts to go down. And then after a while, the population starts to go up again. Okay, so if you want to find out when the population starts to decline, then really you're trying to find out when the gradient is 0. So this is the gradient graph. Okay, you see this is the time when the gradient is 0, and then because look, if you look at this point here, the gradient here is 0, and then if you look at this here, the gradient here is 0. So the time at which the population declines is here, which is also here. Okay, and the time at which the population starts to grow again will be somewhere around here, which is this point here. Hang on, to be more accurate, it should like it's when you look at this here, when it equals 0, that's when it's the population starts to climb again. So this time here is when it starts to climb again here. Okay, but the question is, find the growth rate at time equals 1. Okay, so 1 hour, what's the growth rate? Okay, so press pause and have a go. Okay, so to do this here, you should be looking at this equation here. Okay, so the growth rate is given by b prime of t. Okay, so it's basically you putting the 1 into this t, and then you putting basically it's right here. This is your answer. Okay, the y value here. Well, anyway, put t into this thing here, and then you will get this. Put 1 into there, and then you will get this whole thing here, and then it's just a matter of tidying up. So here you can think of it as this thing here. Take away, well, think of it as it's like blah 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 here. Take away 2 elephants, and then you plus 1 elephant. That's like you taking away 1 elephant. Okay, well, basically, this is the same as this, and you've got to take away 2 elephants here, and you've got 1 elephant here. So that's just the same as saying take away 1 elephant. Well, do whatever way you want, and then it blah 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 here, and then blah 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 here, and then it gives you minus 60,000. So so the growth rate at time equals 1 is minus 60,000. Okay. All right. So yeah. Okay.